Hey, Course 2 students, whatever time of day it is, whether it's morning or afternoon, welcome to math class. This is your teacher, Mrs. R, and I just want to make this as close to what we normally do in class as possible. So, seeing as how I normally don't start with a joke, why don't I do that today? Remember, we were working on angles and things, and I'd just like to say, how do you keep warm in a cold room? Okay, give up. You go to the corner because it's always 90 degrees. Hey, just a little reminder right here that this is a website I'd like you guys to go to, Fact Monster. Make sure you're doing those flashcards. Get your speed up for addition, subtraction, multiplication, and division. And we'll see how you are when we get back to school. For somebody just tuning in, this is a classroom for my kids from BV, my Course 2 math class, while we are in COVID quarantine. And this will be lesson 41. Kids, reminding you that your table of contents needs to be filled in your math notebook. I had to fill mine in after I got home. We are all ready for lesson 41. So if you will make sure that you have done what you need to do. Let me see if I can zoom in on this a little bit. Going the wrong way. Zoom in. Nope. Zoom in. There you go. And you can, remember this is such the cool thing about video, is that you can stop or pause or take a break, use the bathroom without a pass. You can do whatever you need to do to make sure you're comfortable and ready for class. All right. Should I try another joke? What did one math notebook say to the other math notebook? Leave me alone. I got my own problems. All right, enough corniness and cheesiness. We finished off with a test and we were doing stem and leaf, box and whiskers. Anybody remember all that? And all the kittens and boxes, but we are ready now to start page 116, and this is lesson 41. So get your notebook out and let's get this going. Lesson 41, and today's date is, well, this is supposed to be for Monday, which is the 27th or 28th, I'm not sure. But my actual date today is the 25th. So let's see, Wednesday. At any rate, it will be there for whenever you want to do it. All right, focus in, focus in. And this will be Monday in March and 2020. I'll go back and edit that in just, I'm sure, as you will too. All right, our lesson today, lesson 41, will be on using formulas. And with those formulas using the distributive property. Using the distributive property, lesson 41. Okay, we have in the past already talked about how to find the area of a rectangle or any square or rectangle for that matter, and we used an equation that I said was A equals L times W, and you'll remember that the A stands for, that's right, area, the L is the length, and the W is the width. Okay, and this is a formula. Right there, formula. Kind of like a recipe when you're in cooking in the kitchen or something like that. You follow the formula, you follow the recipe. And we've already been using this. So if I have an 8-foot wide rectangle and a 4-foot wide rectangle, sounds like somebody's closet maybe, we can follow the formula to find out the area. We can follow that area is length times width. Remember, you always start with the formula and then plug them in And then you can do the multiplication. 8 times 4 is, and feet times feet is, so we know that the area of this particular rectangle is 32 feet squared. Easy enough for that formula. What if I want to find the perimeter of that same rectangle? We're going to use a different formula. We're going to use the perimeter formula. Perimeter. The perimeter formula for rectangle is perimeter is 2 lengths plus 2 widths. Okay, let's try plugging that in. 2 times the length, which is 8, and 2 times the width, which is 4. And again, we're dealing in feet and feet. So 2 times 8 is 16. 2 times 4 is 8. And we have our feet times feet, which is going to give us, ooh, we're not doing feet times feet, are we? This is linear, so it's just feet plus feet, which means it's going to be how much? 16 plus 8 is? That's right, 24. 24 feet, and because it's the distance around the rectangular, we're just adding it up. It's not feet squared. Okay, that's simple enough. Perimeter formula. Did you know that there is a second perimeter formula? We're going to label this one number 1. There's another way to do this. And we're going to label that number 2. Perimeter number 2. Goes like this. Perimeter is equal to 2 times the length plus the width. 2 times the length plus the width. Does that really work? Well, what's the length? 8. What's the width? 4. If we keep following down, we carry our 2 down, and what's 8 plus 4? It is 12. And 2 times 12 is how much? That's right, you've got it. 24 feet is the perimeter of this rectangle. Now, what was different about the way we did these two things? 1, we took the length and added it together, and then we added that to the width 2 times and came up with the perimeter. So we took 1 and 1 and then added it to those 2. In this one, what we did was take the length and the width and multiply by 2 to get the other side. Pretty interesting. All right, now then, what we actually did here between these two perimeters is called the distributive property. We need a definition for this. The distributive property says it's actually the distributive property of multiplication over addition. That's the fancy thing, but we just pretty much always call it the distributive property. But it is multiplication over addition, and we're going to show you how this works up here. All right, multiplication is the distributive property over addition. Let's look again at our two formulas. Our two formulas are perimeter equals 2L plus 2 width, and perimeter equals 2L plus width. There's our two formulas. If we bring in a totally new rectangle, and we're going to say that it has a 30-inch length and a 20-inch width. Let's try it out using our two formulas. Okay, over here, we're going to say 2 times 30 plus 2 times 20. So we would have 2 times 30 is 60, and 2 times 20 is 40, so that our perimeter would be 100, check your units, inches. The distance around this rectangle is 100 inches. Okay, let's see if we can put it into the other formula. 2 times 30 plus 20, and you can see right off the bat that this is going to work very nicely. 2 times 50, which turns out to be how much? 100 inches as well. Our perimeter is 100 inches. Either way, it is the same. So we have proven that. I need to go on to the next page. Probably you do too. Okay, get our heading at the top, 117, and this is lesson 41, continued. All right, so we're going to move into a definition now for the distributive property, and here's what it's called. And I will let you just call it distributive property when we're having to do it in justifying math problems. But please note, on a test or a quiz, it is actually called the distributive property of multiplication over addition. Multiplication over addition. And this is not really how you would write it. That's just a Mrs. Rutherford little code there. All right? And what it says is, we can take some number A and distribute it, like passing out cookies or passing out papers in class, with multiplication, because this is multiplication in here, A times this, over the addition. And it goes like this, A times B, and then A times C. But you keep the plus sign. So A times B is AB, and A times C is AC. This is the distributive property. And how did that look with our our perimeter formula? It looked like this. It looked like 2 times the length plus the width. So we would have 2 to the L and 2 to the W. Right? And we already proved that this works, so we know that algebraically, using our algebres here, algebraically, A times B plus C is the exact same thing as AB plus AC. That's how the distributive property works. Okay, let's try a little sample here, and we're almost done with our lesson. If I have 6 times 20 plus 5, could you show me 2 ways to solve that? Yeah, absolutely you can. So one way would be to go 6 times 25. Oh my goodness, I'm going to have to do some math. 6 times 25. Well, I know that 4 times 25 is 100, and 2 more times 25 is 50. So I'm going to say 150 without doing the math. Oh, I better do the math just to be sure. There's 5 times 6 is 30. 6 times 2 is 12. Plus 3 is, come on, quick, get it, 15. There you go. So this would be one method to do it, where we simplify within the parentheses and then do the multiplication. The other way to do this is using the distributive property. So we're going to go taking the multiplication over and the addition. So we're going to take 6 times 20, keep your plus sign, and then the 6 times 5. Well, 6 times 2 is 12, and we multiply by that 10, plus 6 times 5 is 30. And I know that 120 plus 30 is going to give me 150. So there we have done using the distributive property of multiplication over addition. The distributive property of multiplication over addition. But Mrs. Rutherford, what if there's a variable? I know they're going to give us a variable. Well, okay, we'll do that. Here you go. 2 times 3 plus n. Oh, let's make it just a little bit harder and add something on the outside there. All right, so here's what we're going to do. We cannot add the 4 and the 2 because this is multiplication and this is addition. We can't even add 3 plus n because we have no idea what n is. So the only thing we can do at this point is what? That's right. Use the distributive property. All right, so we're going to take our 2 and carry it over both of those. And by the way, the arrows are good. When you get into Miss Mitzelfeld's math class or Mr. Lichtenwalter's math class, you can probably skip the arrows because you're going to be so used to it. But for right now, it's a good thing. And I even recommend circling that plus sign and dragging it down right there. So 2 times 3 plus 2 times what? 2 times n. Boy, does that look familiar. What am I going to do with this? Just forget about it? Oh, absolutely not. You got to keep that part of your problem. Bring it right down. Well, it's starting to look a little better. Can I do anything here? Yep, I certainly can. 2 times 3 is how much? 6 plus 2n plus 4. Okay, that was simplify. And I'm going to call on you to go way back in your brain because I know you know 6 plus 4 is 10 and then we still have the 2n. But what property is going to allow us to add the 6 plus the 4? Does anybody remember? Looks like everything right here is addition. Can we use the commutative property of addition? Absolutely. The commutative property of addition allows us to take the 6 and move that 4 right here and the 2n right there. Then I'm going to simplify again and get 10 plus 2n. And I want to let you know, though, that this is not Algebraize. Algebraize really likes to have that 2n up front, so let's just do the old switcheroo. 2n plus 10. We haven't figured out what n is, have we? Well, at this point, we can't. All that we can do with this problem, when there's no equal sign, all that we can do is simplify to make it easier. And someday, when somebody supplies us with an n, we'll know exactly what the value of this is. But for now, that's it. Oh, by the way, what other property did we do right there? You're right, the associative property of addition, which allows us to group two things. Because remember, math is binary. Math is binary. All right, kids, well, that's it for today. Be sure to add lesson 41 to your table of contents. And you can stop and pause and get all of these notes in your binder, just as easy as you can. I'm going to be putting the assignment up on FACS. Check our Course 2 Math. And look for today's assignment for lesson 41. Hope you're having a good time. Keeping you in my prayers. And happy math.